Hello everyone and welcome back to my YouTube channel. This is the third lecture on motion. In my previous class I have explained the physical quantities like scalar quantity, vector quantity and distance. But now in this class I'm going to explain displacement, velocity, uniform motion and non-uniform motion. Okay, let's start. Here we have displacement. Let's read the definition first. The change in initial and final positions of the object in a particular direction irrespective of the nature of the path taken by the body is called displacement, or displacement is the shortest distance covered by a moving body between the initial and final position of the object in a particular direction. Therefore, displacement is equal to final position minus initial position. Here, I'll give you one example. Let's say this is A and this is B. From A to B to reach B, your path is like this. Then this path is 50 kilometers, but the actual displacement, the actual length straightward is only 20 kilometer. Only 20 kilometer. But your path, the way you travel to reach B is you follow this path and you covered 50 kilometers. In this case, your displacement actually is only 20 kilometer. Okay, but the distance that you covered is 50 kilometer. This is the difference between displacement and distance. In displacement, irrespective of the path that you followed, you have to measure the distance straightward. You don't have to measure this way. You just have to measure the shortest way like this. So this is called displacement. But in case of distance, you have to measure the actual path that you have covered. That is, from A you follow this path and to reach B you covered 50 kilometers. This is the actual distance that you have covered, but the actual displacement will be only 20 kilometers. This is displacement. Then the SI unit of displacement, the unit of displacement is meter. Yes, SI unit of displacement is meter here. Let's remove this one. Cannot read. Here the SI unit of displacement is meter and it is a vector quantity. Since to describe displacement you have to mention the direction towards here. Your path is like this, but actually your displacement is towards south. From A to B. See, B is south from with respect to this A position. Okay, so your displacement, your direction here is southward. Let's go to the next. Here we have uniform and non-uniform motion. What is uniform motion? When an object covers equal distances in equal intervals of time, however big or small the time interval may be, the object is said to have uniform motion. So let's give example here. Here a boy is riding motorcycle. So he traveled, these are equal path. Let's say these are equal distance. Let's say this is 20 meter, and this also 20 meter. 20 meter, sorry, 20 meter, this also 20 meter, this also 20 20. From here he takes 5 minutes to cover this 20 meter. Again from here also he takes 5 minutes to cover 20 meter. Again from here he takes 5 minutes to cover this much length. Then here also 5 minutes. Okay, that means to cover 20 meters he takes 5 minutes. In each 20 meter he takes 5 minutes. Okay, then that means his motion, his movement will be uniform since he covered equal length in equal intervals of time. So this is called uniform motion. Okay, akal thui zong minute nga chungin 20 meter cover heta po 20 meter thau minute nga chungin heta po 20 meter thau hawang khan uniform motion ani ma a cover zat a distance covered zat kha a time taken in ang thapa khanin ai ang ve thap sia hi wang ya hi uniform motion ting dan sai ni ma. Then what about non-uniform motion? Non-uniform motion, let's read the definition first. Non-uniform motion, when an object covers unequal distances in equal intervals of time. However big or small the time interval may be, the object is said to have non-uniform motion. In this case, the time taken, let's say this much distance is 20 meter and this much distance is 30 meter, this is 40 and this is 50. Okay, to reach from here to there he takes 5 minutes. Okay, here 5 minutes, and to reach from here and there this much length is 30 meter, he takes 7 minutes. Sorry, here also 5 minutes since this is unequal non-uniform motion. Here also 5 minutes. 40 meter also 5 minutes. 50 meter also 5 minutes. That means time taken by him to cover different distances is same. Here 20 meter, to cover 20 meter he takes 5 minutes. To cover 30 meter he takes 5 minutes. 40 meter he takes 5 minutes, and 50 meter also he takes 5 minutes. That means time interval remain constant. Time is unchanged, a time taken kadanglam lawa, but the distance covered in this case are different. Adanglam vakani ma. In this case we can say this is non-uniform motion. If he covered equal length in equal interval of times, that motion is called uniform motion. But if he covers unequal length in equal intervals of time, that motion is called non-uniform motion. Okay, now let's go to the next. Yes, here we have difference between uniform motion and non-uniform motion. The object covers equal distance. In case of uniform motion, the object covers equal distances in equal interval of time, as I said earlier. But in non-uniform motion, object covers unequal distances in equal interval of time. Then number 2, straight line graph is obtained in a distance time graph. In uniform motion, straight line graph is obtained in a distance time graph. Let's write here one graph. Here we have the vertical line is called y-axis, the horizontal line is x-axis. Okay, then this horizontal line, let's say this is time, then this vertical line is distance. In case of uniform motion, let's say this is origin or the starting point. It should be, according to this statement, straight line graph is obtained. In this case, the motion should be straight like this. It shows that this from 0 to this much length is, let's say, 10 minutes, and this much length also 10 minutes, and this much 10 minutes. Then here this is 5 meter, this also 5 meter and 5 meter. Okay, 10 minutes you will cover here, again another 10 minutes you will reach here, another 10 minutes. So it's this line is straight. Okay, but in case of non-uniform motion, the object covers unequal distances in equal interval of time. Here the graph, the curve shape graph is obtained in this case. Okay, let's write another graph. This is y-axis and this is x-axis, origin. Time, here time difference same, time frame is same, here 10 minutes, here also 10 minutes, and here also 10 minutes. Then distance will be unequal in this case. See, initially within 10 minutes he covered this much distance. Again, his if the speed slowed down, then time will increase but distance will not increase. Okay, then again it will be like this. Okay, see, in the first 10 minutes, okay, this, let's say this is 5 and this is 7 and then this is 9. Initially in within 10 minutes he covered 5 meter, then another 10 minutes he covered only 2 meter, then another 10 minutes 9 meters. So the distance covered within equal intervals of time is different in this case. So this is non-uniform motion. Then here there is example of uniform motion. A train moving at a constant speed of 120 km per hour. So the speed remains constant in this case. So this is uniform motion. But what about non-uniform? Here is the example. A ball is thrown upward. Yes, if you throw a ball upward, initially the velocity will be very high, but slowly that velocity will decrease. Then at last it will be 0. Then it will fall back to the ground. Okay. In this case, a ball is thrown upward is non-uniform motion. The next, what do you have? Yes, here we have velocity. Velocity is defined as the distance covered by a body per unit time in a given direction. Here, velocity and speed you may mix up. In case of speed is distance by time. We say distance by time. Distance and okay, here I will give one example. Here a city, let's say this is A, and here another city B. Then in straight, these two cities are 200 kilometers apart, but the path that connect these two cities, let's say, is 500 kilometer. 500 kilometer. Okay. Then in this case, you are traveling with a speed of 50 kilometer per hour. Okay, let's say 500 kilometer per hour. You use 500 kilometer per hour speed to reach this city, B city. Okay. Then what will be? Okay, let's say your speed is not like that. Tama can reduce ang. Okay. You use 50 kilometer per hour speed to reach this B city, and actually what is your velocity in this case? Velocity is given by displacement by time. Displacement by time. Here actually your displacement is 200 kilometer, but the path that you have covered is 500 kilometer. Your velocity will be okay, your time taken here, let's say your time taken is 5 hours. 5 hours. Then velocity will be 200 divided by 5 is 40 kilometer per hour towards what? Towards west. That will be your velocity. You have to mention the direction in this case. Okay, velocity is a vector quantity. You have to indicate the direction also. But in case speed is a scalar quantity, only magnitude can is enough to define the speed. Magnitude kan mamoni speed define nanjan. But in case of velocity, you need both magnitude and direction. Okay, this is velocity. Then your homework will be, let's go back. Yes, here there's the definition of displacement, uniform and non-uniform motion, difference between uniform motion and non-uniform motion, and velocity. You have to copy it down to your notebook, all these important statement. Here also, and here also. You have to copy it down to your notebook and you have to submit it to me. Heng ho zong zong a statement poi mo koron zia ho zong zong hi in zia ka nga notebook a chuan dar sari ma in min ron thon don nia. Thank you.